Hello, this video will be on grammatical trees and parsing, but I'll start with a little bit of a discussion of grammatical ambiguity. So, let's have an example of grammatical ambiguity. Groucho Marx tells this joke. He says, "Last night I shot an elephant in my pajamas. How it got in my pajamas, I'll never know." And this works as a joke because you expect that it's Groucho that was in his pajamas when you hear, "I shot an elephant in my pajamas." And then he says, no. And the joke is that it was the elephant that was in the pajamas. And this joke is possible because the phrase or the sentence, "I shot an elephant in my pajamas," is grammatically ambiguous. The "in my pajamas" phrase could grammatically attach to the word "I" at the beginning of the sentence or attach to an elephant at the end of the sentence, and you expect the "in my pajamas" to attach to "I," but he tells you no, it attached to "in my pajamas," or excuse me, to "elephant." So another example of this is this sentence, apparently from the news: "Enraged cow injures farmer with axe." So again, grammatically ambiguous. There's this with axe. Does it attach to injures, or does it attach to farmer? So is it the farmer that has an axe that was injured, or is it that using an axe, the enraged cow injured the farmer? Well, there's an intended reading, but the sentence is grammatically ambiguous. And natural language contains grammatical ambiguities all over the place. And there's nothing terribly problematic about that. Sometimes it can be problematic in communication, but certainly in these two cases, it tends to be clear, which of the readings is the intended reading. But for studying logic, it's kind of a problem, because in logic, we're interested in properties like validity that stem from a sentence's formal properties and not its content properties. So if a sentence is grammatically ambiguous, it has different readings, and those different readings are going to have different logical properties because they're formally different. We don't want that. We don't want to have to worry about that, and so we want a language that's not grammatically ambiguous. We want a language that's grammatically univocal, where if you see a sentence, this is how the parts fit together, this is the only way the parts fit together. And in fact, our language is grammatically unambiguous. Each sentence could have been built by our rules in only one way. Now, you could prove that. We're not going to, but it is in fact not ambiguous. So this is an important property of our language. Okay, so having observed that, that's why we're using a logical language. I now want to talk about the notion of a main connective, which is going to help us to understand grammatical trees and the parsing activity, but we need this notion first. So we're going to start with some examples. So here's a sentence, "not P," and we want to know what is the main connective, and the answer is that it's the negation. An aside here, it's a little bit strange to call the negation a connective. You think of a connective as connecting things, so there are two things that it connects, like the conditional connects two sentences, whereas the negation here isn't connecting two sentences, it just hooks onto one sentence. Nonetheless, the word connective is used in this way to include the negation sign, and in logic, that's the way the word connective is used, and we're just going to go with that. So, okay, why is the negation the main connective of this sentence? Well, we already had a sentence P, and we added the not to make this new sentence. So the not symbol is the main connective because it's the one we added to something that was already a sentence to form the new sentence. Okay, how about this sentence, not P? In this case, the main connective is the leftmost negation sign. There are two of them, and it's the one on the left. And why is it the one on the left? Well, because not P is already a sentence, and we form our new sentence by adding not P to the old sentence. And so the leftmost negation sign is the one that was added to form our new sentence. How about if P then Q? Okay, here the main connective is the arrow. Why is that? Well, because we had the sentences P and Q, and we added the symbol not to form our new sentence. And so that's why it's the main connective. Now, okay, how about this sentence? Not if P then Q. What's the main connective here? Well, take a guess. It's the negation sign. Why is that? If P then Q is already a sentence, to form our new sentence, we add the negation sign. And so this new sentence, its main connective is whatever we added to old sentences to make the new sentence, and what we added to old sentences to make the new sentence is the negation sign. How about this sentence? If not P, then Q. Here, what do you think? It's the arrow. Why? Well, same explanation. not P is already a sentence, Q is already a sentence. To form a new sentence, the connective we add is the arrow, and that makes it the connective of the new sentence. So the main connective of a sentence is the connective that's last added in building up the sentence. It's the connective that's also added to one in the case of a conditional, or two sentences in the case of it's added to one sentence in the case of a negation, and to two sentences in the case of a conditional to form the new sentence. Each sentence of our logical language has only one main connective. In a language that's grammatically ambiguous, a natural language like English, a sentence might have, on each reading of the sentence, it has only one main connective, charting the way, if it was built up this way, then this is the connective that was added last. If it was built up that way, then that other connective is the one that was added last. But since our language is not grammatically ambiguous, each sentence has only one main connective. And note that this gives us a little test if we want to know what is the main connective. It's the one that if we remove it, and if it's a conditional external parentheses, then we're left with the right stuff. So, in other words, we're left with what you say, here's the connective, there's a rule that goes with this connective. It says you have to have two sentences or you have to have one sentence. And if that's what you have when you remove the connective, then indeed that was the main connective. And we'll see how to use this test later on. But I want to make an observation about main connectives first, which is that they're what tell us what kind of sentence a sentence is. Is it a conditional? Is it a negation? And the difference between being a conditional or being a negation is pretty important. And one way we can see that is to look in English. So I'm going to describe a little scenario, and then I'm going to consider two sentences describing that scenario to draw out the contrast between having conditional or negation as the main connective. So suppose we have the following situation. I'm in a good mood, and so if I have a cookie, I'll be happy. But also, I'm in such a good mood that even if I don't have a cookie, I'll still be happy. So either way, whether I have one or not, I'm going to be happy. Okay, so if I don't have a cookie, will I be happy? Yes. If I don't have a cookie, I will be happy. So this sentence is true. Now consider the sentence, it's not the case that if I have a cookie, I will be happy. This sentence is right? Why? Well, we know that if I do have a cookie, then I will be happy. So the denial of that conditional, the negation of the conditional, what this sentence is, it's not the case that if I have a cookie, I will be happy. That negation is false, because the negated sentence, the conditional, what the negation is applied to, is true. So the first is a conditional, with its main connective is a conditional, and it's the antecedent inside of it is negated. The negation is inside the antecedent. In the second case, the sentence is the negation of a conditional, and so a negation is its main connective. So, a couple points. First, main connective, different kinds of main connectives say different things. And secondly, when there's no grammatical ambiguity, that's nice, because then it's clear which claim we're making. And in these two cases, there is no grammatical ambiguity. So, how do we always avoid ambiguity in the logical language? With parentheses. So here are two sentences, if not P then Q, and not if P then Q. So these are just like those two sentences that we saw in the previous slide. They say different things. In the first, the antecedent not P is a negation, while in the second, the whole conditional is negated. So the first says that not P, that's enough for Q, so not having a cookie is enough for me being happy. The second says that P by itself isn't enough for Q, so it says that having a cookie is not enough for me being happy. So the parentheses are what tell us which logical symbol is the main connective. The parentheses always come with the conditional, and so they're always inserted by the conditional, and so we know that they're going to surround the antecedent and the consequent. So we know on the first sentence, since the parentheses are outside of that not is in the antecedent. Whereas in the second one, since the negation is outside the parentheses, the negation is not part of the antecedent, and so it must instead be a negation of the whole conditional. So, okay. If we were to remove all parentheses from our language, we would get ambiguity. So if we had a language where there are no parentheses and then we came upon this sentence, we would say, well, I don't know what sentence this is, what its grammatical form is. Is the negation apply to just P, or does it apply to the whole conditional? And, well, either way. So this would be grammatically ambiguous. So we're not going to do that. But we are going to drop parentheses a little bit. we're going to have an informal notation that says we can drop the final set of parentheses that's used when building up our sentences. So this thing here, negation P arrow Q, is not a sentence, but it is not formally a sentence, but it is informal notation for parenthesis, not P arrow Q parenthesis, right? Why? Well, we know that you can drop the final set of parentheses. So if we come upon something that is by itself not a parenthesis, is not a sentence, but we were to add parentheses to it, then it would become a sentence. Then we say the initial thing without the sentence, that's informal notation for the thing with the parentheses. And we're going to count those as sentences. Most officially they're not, but informally they are, and we're going to pretend that they are. Because we know whenever we come upon a sentence that's lacking parentheses, we always know how they have to be restored. They always have to go on the outside. So if we have if P then Q, that's the formal version. The informal version, we drop the external parentheses. But we can do this with bigger conditionals. So we have if P then Q, then R, and so we have two conditionals, two pairs of parentheses. We can drop the external parentheses, and so we have we retain the parentheses that come with the conditional between the P and the Q, but we drop the parentheses that come between, on the one hand, if P then Q, and on the other hand, R. That second condition, that conditional officially requires parentheses around the whole thing, but we're going to let them go in informal notation. Okay, so that's about main connectives and informal notation. Now we can get to trees. So say we have here some sentence letters, and they're sentences according to Rule 1. Now Rule 3 says if you have two sentences, you can put them together and form a conditional if you put parentheses around the whole thing too. So if P then Q is a sentence. And we have P, and Rule 2 says, oh, if you have a negation, you can put that on the front of a sentence, and you get a new sentence, so here, not P is a sentence. Rule 3 again says, oh, well, if you have two sentences, you can put a conditional between them, parentheses out around them, and you have a new sentence. So here we have, if P then Q, then not P. Now what we have here is we have a little diagram that displays how the big sentence, if P then Q, then not P, was built up. And we call this a tree. It's a grammatical tree, and each sentence has a grammatical tree. Well, if it's a sentence letter, it doesn't have a tree. If it's a complex sentence, then it has a tree. And what the tree does is display how the sentence was built up from sentence letters. So if you come upon a sentence, skipping something here. So, a couple things. This demonstrates that, right, whenever starting with atomic sentences, we can apply rules to get new sentences. And you can repeat this process indefinitely. There's nothing that says, oh, you've applied. There's no rule that says, oh, well, you can apply 10 rules and then you have to stop. You can just keep going and going and going and building bigger and bigger and bigger sentences. So you could have put if R, then this whole thing if we wanted to, and made a new sentence. And the tree of the sentence, it displays the way in which the sentence is built from sentence letters. So if you come upon a sentence without the tree, you could build the tree. And how you do that is at each step, you remove the main connective and write down the parts. This is why it's called this activity of build. If you start with a sentence, a complex sentence, and you do the tree backwards in this way, it's called parsing because you're breaking the big sentence into its component parts. And you do it in steps. So at each step, you remove a main connective and you write down the parts that the main connective was attached to build the new sentence. So here we have if P then Q then not P. The main connective is the second conditional, so we remove it, we get rid of its parentheses, and below it we write down the two sentences that conditional connects. So we have if P then Q, and we have not P. And then we can repeat the process, and again we remove the main connective and write down the component sentences. In this case we get down to the sentence letters P and Q, so this side of the tree is done. And over here we again just remove the negation, we get to P, and so now our tree is completed. So on the one hand, if you're building a sentence, you can draw a tree that will, build it up. On the other hand, if you're given a sentence, you can generate the tree by parsing it, by breaking the main sentence, the initial sentence, into its components step by step by step. So that's what parsing is. We break a sentence into its parts. At each step, we identify the main connective, break the sentence into its immediate parts. We're done when we get to the sentence letters. And this produces the grammatical tree of the sentence. It displays how is the sentence built up out of its parts. So in the module, and so your first set of exercises will be doing some parsing exercises, and you'll be doing them in the Logic 2010 program. And the Logic 2010 program has a parsing module that you'll be doing those problems in, and I will be demonstrating, doing some examples in another video. So you'll be given a string. It may be a sentence, it may not be. You'll have to decide, is it a sentence or is it not? And is it a sentence of formal notation, or is it a sentence of informal notation? And then if it is a sentence of either, you'll have to parse it. You'll have to break it up. If you're not a sentence, you don't have a parsing tree, because a parsing tree displays how you're built up according to the rules. And if you're built up according to the rules, then you're a sentence. So if you're not a sentence, you weren't built up according to the rules, so there's nothing to display about how you were built up according to the rules. So one last little thing, some non-sentences. So this is not a sentence. Why not? It's not a sentence because A is not a sentence letter. Sentence letters are capital P through capital Z. Capital A is not a sentence letter, so this is not a conditional surrounded by two sentences. P parenthesis Q is also not a sentence. We don't have any rule that would enable us to just put down two sentences and put a parenthesis in between them, so it's not a sentence. So these are the kinds of strings that you'll see that you'll identify as non-sentences. So at this point, you can watch one of two videos next. You could either go straight to the parsing examples video and see me do some parsing problems in the module, or you could first download the program and watch the Logic 2010 video and download the program, and you could then follow along and watching the parsing examples. And I would recommend that you do that, that you watch that video first and download the program. But you can do it in either order, whatever works for you. Bye.